Alright, so we're given this problem with a bunch of combinatorial expressions here, and we're really just asked to find the sum of them, right? And so this is just 20 choose 10 times 15 choose 0 plus 20 choose 9 times 15 choose 1. Oh my god, that's gonna go on forever. Alright, so, well, what can we do with this? Well, the first thing you want to try when you don't know really what to do is just give it a go. So let's try. We'll try. So we want first. Let's just calculate this out. That's gonna be 20 choose 10. 20. Oh god, this isn't gonna be fun. If we want to do 20 choose 10, that's 20 times 19 times 18 times 17. Oh no. There's no way we're going to be able to calculate this. So, what can we do then? Well, when you can't do something, as Richard Russick says a lot, when you can't do something smart, do something stupid. Now, there's really no way to smartly manipulate it, and we tried being stupid, so smart and stupid both don't work. Which then means there's something we're clearly missing in this problem. Let's think about it this way. When you're faced with combinatorial expressions, you're going to want to see if you can do a group forming or a block walking kind of argument. And these are things that are really crucial to solving AMC, AIME kind of problems. Always keep in mind that block walking. So let's try for the first time, let's try block walking. Well, we've got 20 choose 10 times 15 choose 0. That's saying we want to go 10 spaces in a block of 20 by 15. Well, that wouldn't really work, right? Because then what we've done is we've said we're choosing 20 choose 10. Well, clearly that isn't working. It's not working out, and now I'm kind of confused as, well, where the heck are we going to go with this? Because if it was a block walking argument that made sense, then it would be something like 20 choose 20. Even a block walking argument wouldn't make sense. So we can't do that here. So we're left with nothing else to try but committee forming. So we've got repeated binomials with 20 and 15. So that's going to make us think about, what if we considered two different groups? What if we considered two different groups? So what I mean is, if you take a look here, all of these in common, all of these, what do they have in common? Well, they've got this. They've got the 20s, they've got the 20s and the 50s. 20s and the 50s. And the 15s, sorry. 15s in common. So what can we really do with this? Well, we're gonna make two different groups. We're gonna say here, let's make group 1. Right? And this is just a group of people. So we're gonna call this group 1, and inside group 1, there's gonna be 20 people. And then we're gonna have a little bit of a smaller group called group 2. And inside group 2, there's gonna be 15 people. Now, what if we tried just kind of analyzing? So if we just took a look at these right here. So let's just take a look at this sub expression, right? Let's take a look at this kind of sub expression right there. So what we're seeing here is we're taking right out of here, we're taking 10 people and we're taking 0 people. So we're taking 10 people from group 20 and 0 people from group 15. All right, that's great. What about this one? What about this one right here? Well, this one, This one we're taking 9 people here. We're taking 9 people here and 1 person here. Wait a minute, that's still 10 people. We're still taking 10 people in total. Alright, I think we're onto something. What if we tried just simply analyzing this? Well, that's going to be 8 people here and 2 people here. Okay, great. So we've got something. In all of these, we're taking a total of 10 people from these 2 groups. And suddenly, it all makes sense. See, what if we considered the common group here? The common group, call it group 3, which contains all of group 1 and group 2. Group 3. So when we're taking here, we're taking some amount of people, say k people, and we're taking 10 minus k people. That's a total of, and sorry for the tight cramping, that's a total of 10 people. So if we consider this is then just really, it's going to simplify it all the way down to the number of ways to choose 10 people from the sum of the number of people in these 2 groups. Now we again said 20s and 50s. 20 plus 15, that's 35. So our answer is then the number of ways to choose 10 people from a group of 35. And so this is going to be our answer, right? This is our answer. So now you may be wondering, well, how are we going to simplify this? How is this making sense? And the answer is there's no way to simplify this. And unfortunately, that's just the way it is. 35 choose 10 is like in the millions. It's somewhere around 1700 million, if I believe. And so really, what you would just do there is you would say, okay, that's our answer. We're going to go on with it. Hopefully it's part of your answer choices. It's 1800 million. No, 180 million. And so that's pretty much it. Right? So we're done. Not quite. Not quite. We have to make sure that when we're doing 35 choose 10, there's no possibility that they're not taking some amount from here and the rest from here. Right? We have to make sure all of the ways that we are counting these 10 people are included from just taking from this and this, right? Are included here. That's what we want to do. But that's obviously making sense, right? Because if we're going to take 10 people, we're either going to take them from this group or this group, right? So that's just k from this group and 10 minus k from this group, and that's exactly this. So we can go down to 35 choose 10 and back up. That's a 1-to-1 correspondence, and our answer is then clearly 35 choose 10. And that's really what we're going to have. So that was a very interesting and, in my opinion, a very fun and useful combinatorial problem. Now, if you did enjoy, please don't forget to like and subscribe and share this with people you know. My name is Mathematics, and I will catch you guys in another video. Peace.